Imagine two ancient stars, each the size of Earth, but containing the mass of our Sun, hurtling toward each other at incredible speeds. When they collide, the explosion creates something astronomers thought was impossible. Now the Hubble Space Telescope has uncovered evidence of this rare cosmic event, and it's rewriting everything we know about stellar death. This is the story of WD 0525 plus 526, a star born from violence, which will be simply called WD from now on. So, what do you think? If this is possible, imagine what else could be possible. I would love to hear from you in the comments below. To understand this discovery, we first need to understand what white dwarf stars are. When a star like our Sun exhausts its nuclear fuel, it doesn't go out with a bang. Instead, it gently sheds its outer layers, creating beautiful planetary nebulae. What remains is the star's incredibly dense core, compressed to the size of Earth. This white dwarf contains as much mass as our entire Sun, packed into a sphere no bigger than our planet. A teaspoon of white dwarf material would weigh as much as a car. These stellar remnants are among the most common objects in our galaxy. But there's a limit to how massive a white dwarf can be, called the Chandrasekhar limit. Most white dwarfs have masses up to about 1.4 times that of our Sun. Ultramassive white dwarfs that exceed our Sun's mass are incredibly rare. Until now, astronomers weren't sure how they formed. But in 2024, an international team of astronomers made a groundbreaking discovery. Using the Hubble Space Telescope, they focused on a white dwarf called WD. Located just 130 light-years from Earth, this star seemed ordinary at first glance. But WD is no ordinary white dwarf. It's 20% more massive than our Sun. Dr. Boris Gensic from the University of Warwick led the investigation. Using Hubble's unique ultraviolet capabilities, his team discovered something extraordinary. Hidden in the star's ultraviolet light were traces of carbon in its hydrogen-rich atmosphere. This carbon signature was completely invisible in optical light, only revealed by ultraviolet observations. This carbon was like forensic evidence telling the story of the star's violent past. The evidence pointed to an incredible conclusion. WD wasn't formed from a single dying star. Instead, it was born from the violent merger of two stars. A white dwarf had collided and merged with another star, creating this ultra-massive remnant. The merger stripped away the outer hydrogen and helium layers, exposing the carbon-rich interior. This explained why the star was both hotter and more massive than typical white dwarfs. This discovery was only possible because of Hubble's extraordinary ultraviolet vision. While ground-based telescopes are limited by Earth's atmosphere, Hubble sees the universe in ultraviolet light. This ultraviolet sensitivity revealed chemical signatures completely hidden from optical observations. Dr. Snehalata Sahu, the study's first author, emphasized how crucial these ultraviolet observations were. By analyzing the star's ultraviolet spectrum, astronomers could identify specific elements in its atmosphere. The presence of carbon absorption lines told a story of stellar violence and merger. It was like stellar archaeology, using light to uncover the star's hidden history. Without Hubble's ultraviolet capabilities, this merger remnant would have remained undetected. Once again, Hubble proved its value in revolutionizing our understanding of the cosmos. This discovery challenges everything astronomers thought they knew about white dwarf formation. Previously, ultramassive white dwarfs were thought to form only from single, very massive stars. Now we know that stellar mergers can create these exotic objects too. The team suggests that merger-born ultramassive white dwarfs may be more common than previously thought. This has profound implications for our understanding of stellar evolution across the galaxy. It could also impact models of Type 1a supernovae, which are crucial for measuring cosmic distances. These stellar explosions serve as standard candles for mapping the universe's expansion. Understanding white dwarf mergers is also crucial for gravitational wave astronomy. These cosmic collisions create ripples in space-time that we can now detect on Earth. The discovery opens new avenues for research using ultraviolet spectroscopy. Future space missions could identify more merger remnants hidden throughout our galaxy. This would help astronomers understand how common these violent stellar encounters really are. Each discovery refines our models of how stars live, die, and sometimes collide. WD represents more than just one unusual star. It's evidence that the universe is far more violent and dynamic than we imagined. Across the cosmos, stars are colliding, merging, and creating new types of objects. Each discovery reveals new complexity in the life cycles of stars. For over 3 decades, Hubble has been our window into these cosmic mysteries. From distant galaxies to nearby stellar remnants, it continues to revolutionize astronomy. The discovery of this merger remnant proves that even nearby stars can surprise us. Who knows what other secrets are hiding in plain sight, waiting for the right instrument to reveal them. As we look up at the night sky, we now know that some of those points of light are the products of ancient stellar violence. Even in destruction, the universe creates beauty and complexity beyond our imagination. Ready to dive deeper into the matrix? Watch the next video here to see just how deep the rabbit hole goes. With each observation, we're not just studying distant objects, we're uncovering the violent and beautiful history of the cosmos itself. The universe is full of rare mergers, cosmic collisions, and stellar stories waiting to be told.